Good morning, most likely, to the people listening in at the moment. Welcome to the ioGAS 7.4 webinar, where Putra mainly is going to take you through some of the new features in the new release and explain how they work. Online from the IMDEX side, I've got myself and Putra, but also Sophie Alexander that the vast majority of you would have dealt with as well, just with your queries and questions about ioGAS over the years. So the running order for the webinar is that we're just going to briefly go through a very short PowerPoint, which highlights some of the new features in ioGAS 7.4. Then we'll cut over to a video demo, which doesn't go for too long. And then after the video demo, we'll come back and Putra will show you some of the more intricate moves, if you like, with the new features live running ioGAS within the session. And during and after that, we'll just throw it open for Q&A as well. So while Putra's actually running gas, if you want to ask questions, you can pop them into the comments box and I'll just answer them verbally while Putra is working. As always, we appreciate your support and these new features are the result of your feedback. As always, please email us with any ideas that you have with gas. Rest assured, we do read all of the emails that come through to us, and if ideas are, if we don't understand the suggestion, we'll get back to you and ask. And if it's interesting and fits the strategy of ioGAS, it'll make it into the product eventually, which I think is a theme that you'll see when we go through this PowerPoint, that we do listen and things do make it in. So I'm going to hand over to Putra now and just interject with comments when he's going through, just to add a little bit more color and context. So over to you, Putra.
No worries. Thanks, Dave. Hey, everyone. Good morning, good evening, and whatever you are. So I'm just going to run through a few of the features here in a quick PowerPoint presentation, and I will run through a video of what ioGAS 7.4 is and run through a demo of the software afterwards. So in this release, we have added new features that enhances interoperability with some of the file format that we can bring into the program. And we have also added some features that have been requested by our users before in the past. So some of the things like edit data and merge columns have been requested before by our users, especially, and also user selected variable groups. So those are the features that people have been asking before in the past, and we finally add them into ioGAS. So batch open is a feature that we've added in this release. So I thought I'll start with that. So that's a way for you to bring in multiple files with the same structure and combine them into a single data set. So it's basically, so if you've used the append tool before in ioGAS, kind of works like that, but you're basically appending them all during import all at the same time. So it works really well with the lab data output, so lab-based CSV files and geophysics data files. So those kind of files, they all have the same structure, so the same column order and that sort of thing, and that's what we require in order to bring them in using this batch open function. And it's especially really useful for bringing in geophysics data files in the same format, so you can bring them all in at the same time. And then we have the SQLite import option. So SQLite database has been increasingly used in the community. So we've added that feature in order to allow you to basically bring in a SQLite database straight into ioGAS and choose a table or a view from that database that you can bring into ioGAS. And I'll run through that in a bit more detail once I run through the demo of GAS. And then edit data. So people have been asking for this for a while. So this actually allows you to make changes to the data directly by directly editing cell values onto the data view. So if you open data view in ioGAS, you can click on this button that lets you toggle edit mode, and then it's gonna come up with a red square around the data view, basically telling you that edit mode is activated, and that basically allows you to change any value in text columns or numeric columns. So like if you see a typo, for example, in one of your categorical text column for geology, for example, you can change it easily without having to re-import the file. But you can also edit the content of a numeric column. So so that's one way that you can data doctor it, just by data doctor your data by directly editing a cell content. But of course, it comes with cautionary warning, because if you change the content of a numeric column, that's not going to recalculate any column that's using that as an input column. So think derive columns and calculations that relies on the column that you just edited. You want to add anything to that, Dave?
Yeah, well, there was a reason why we haven't added this feature for many, many years, but we've finally relented. But it's buyer beware if you use it. We've always considered GAS to be the end destination of clean data for interpretive purposes, and always encourage people to, if there are errors in the data, to fix it back in the source so that the next person that accesses that data accesses the fixes. Because if you're editing the data in GAS to fix a particular problem, that won't find its way back into the original database where it should do. Anyway, it's there for convenience, really. We understand that people are busy, so we've put it in there, but that is the reason the big red border appears around it, just to remind people that they're fundamentally changing raw data. But it's there now.
Yep. And it's just a one-click way in the data view, so you can do it while you're looking at your data at the same time, if you want to do it. And then we have this new tool, merge columns. So a few people have asked for this, and this is a way for you to merge multiple numeric or text columns. So I'll run through an example of both in the demo. So I'll run through an example of merging numeric columns, but I'll also run through a pretty neat workflow of merging classified categorical text columns. So if you're merging two alias geochem columns, it will actually support automatic conversion of those geochemical columns. So if you're bringing in, so in that screenshot there, you see arsenic in ppm and percent. So essentially, if you have data that's in percent but not in ppm, and you want to merge the content of the percent column to the ppm column, it's going to do the automatic conversion into the unit of the first item in that list under selected. So it's going to convert the content of arsenic in percent to ppm, and it's going to merge them into that. And then you can choose to create a new column, or you can choose to merge it into the first column, so overriding the content of the existing first column in that list. And it also has pretty robust conflict handling when you have two columns with valid entries in the same row. But if you want to merge text columns as well, that's a pretty neat workflow that you can do, especially with using classification diagrams and things, which I'll show you during the demo. You want anything to add to this, Dave?
No, but well, yes. Again, we finally put it in at the request of users, but we've made it more GAS-like by utilizing the aliasing method within GAS to make it even faster and more useful and less prone to errors. We're always worried about people merging columns of disparate oxide elemental and units as well and ending up with a bit of a mess. So we're trying to handle that automatically.
Yep. So I'll run through an example of actually going from oxide to 8% in the demo as well, and that works really well with this instance. So user selected variable groups. So this is also something that people have requested before, because they take a look at the provided element groups in GAS and think that the element groups they provide is not really suitable for what they're looking at, or not entirely accurate. So what we come up with is a way for people to create their own variable groups, and they can access it within the same session or between ioGAS sessions. So they can choose from a collection of their own variables that they want to look at, and they save it as their own group. So, and I'll show you this later, but one possible workflow is to modify existing provided variable groups. So for example, people have preference of what a porphyry pathfinder group should look like, and we give them the option to do so. Error bars, so that's a new feature as well that lets you plot error or uncertainty information for each data point. So in order to plot this, and I'll show you an example file during the demo as well, but basically you will need to have an element name, and then you will need to have an error information next to that column. So the file needs to be ordered in a certain way, but it basically allows you to plot those error bars right next to, well, around the data point. And yeah, this is something that people have requested before in the past as well, especially when you're plotting lab data. And we've made a number of improvements to PCA tools. So there's quite a few things that we've improved in this, which I'll run through in the demo. But the thing that I'm really excited to show is we are now able to show point density grid and mineral nodes on 2D biplot. And also that screenshot that I have on the screen, that's displaying eigenvector values graphically in order from highest to lowest. And you can basically look at this instead of looking at the eigenvectors tab of numbers. So that's pretty neat. And yeah, we have a whole bunch of other improvements. And I'll just mention this during the demo as well. But one of the things, well, a couple of things that I want to highlight from here is that we've included Osiris demo data now in ioGAS. So if everyone wants to take a look at how we can bring in Osiris data into ioGAS, we provide a demonstration data set that allows you to plot Osiris output in specific Osiris classification diagrams to plot spectral mineralogy result in the diagrams that we provide. So those diagrams have been in ioGAS for a while now, but we just now provide the demo data for people to have a play with it. And then we provide composition nodes based on ioGAS and rock compositions. And then we also improve performance in crosstab in gas. And we also have a quick calc to some selected alias variables, and we allow people to recalculate that to 100%. Anything else you want to finish off with before we look at the video?
Yeah, I just wanted to emphasize, Petra, with, again, going back to the merge function, that it does the unit conversion, but it also does the element oxide conversion. So if you're trying to merge an MG and an MG ppm and an MgO percent column, it will just sort that out for you automatically. So again, it's a very, although merge functions are very common in software, that's a very gas way of doing it. And just to highlight down the bottom there, we've put some ioGAS compositional nodes into the library. That'll be relevant for people working in ioGAS, of course, but that's just a reminder that you can add your own library of rocks into the rock library table in gas and plot those, overlay those nodes on various diagrams and plots. Just a reminder of that. Just one last thing to say before Putra kicks off the video and then the live demo of some of these features is that normally with a gas release, there's a bit more maths and a few other things involved. We've gone back to some of these older feature requests, and one reason for that is throughout the period of developing the 7.4 release, we're actually been working on ioGAS version 8, so it's a major integer release, and that will be our next release. So that one, that's going to have quite a lot of rework going on in the background and lots of much bigger features. So we've been very busy on that actually for about the last 8 or 10 months, let alone working on 7.4. So watch this space. And again, if you've got something, a burning desire to include something in version 8, because we're still working on it, then please send through the emails and we'll have a look.
Thanks, Dave. So now I'll just kick off the video.
In this video, we'll run through the new features of ioGAS 7.4. We will start off by opening data from a SQLite database. So this option can be found from the file ribbon under the new option for SQLite. Navigate to a SQLite database file and click to open. This will take you to this dialog, which will let you select from which table that you want to bring into ioGAS. You will then alias the columns accordingly using the column properties dialog. You can choose to save this imported SQLite database as an ioGAS file. But for now, let's open the data view, where we have added a new feature in ioGAS 7.4 to edit data cells. If we now click on this icon on the right-hand side toolbar of the data view, we can toggle edit mode, where we can make changes to the data directly by editing the cell values. You can see as I do this, there's a red border that appears around the window to indicate that edit mode is now activated. I want to use this opportunity to edit one of my metadata columns, in this case my alteration classification column. So I can edit the data in the cell view. So this cell in particular has high zinc and arsenic corresponding to this row. And you can also choose to edit the content, not just for a text column, but you can also choose to edit the content of a numeric column in ioGAS. But bear in mind how this will affect the results in any derived columns, like calculation results. Now I want to show you how we can create a custom user variable groups. This is a feature that has been requested a number of times before by our users, and it's really useful when you have a number of elements that you want to save as a favorite group. So this function can be found in the select variables dialog. So say if I want to create a group for certain commodity elements for copper gold exploration. So I want to select just copper, gold, and moly in this instance. I'm just going to select these 3 elements, and I can click on this button in the select variables dialog to create my own group. And as I do that, it will be displayed under the user drop-down list. And I can use the same workflow to create a copy of a provided variable group, in this instance, porphyry copper gold group. And I can use this to edit the list of elements to better fit my need. So this is another workflow that you can use using this new tool. So please note that this function only works on alias columns. The next feature I want to look at is on the principal components analysis tools. So we've made a number of changes here, including the ability to calculate more than 12 principal components columns. But in the results window, in the report, we have a new tab here called eigenvector plots. So this is basically a visual representation of the eigenvectors table. And you can use this to visualize your eigenvector values. A new feature that we've added to the 2D biplot is the ability to display point density grid, and also the ability to display mineral and rock nodes. So we can now plot mineral compositions if you're using alias columns like this one as the input for the PCA. On the 3D biplot, we've added a few number changes as well. So in the 3D biplot, it is not possible. So if you use the flash highlighter tool, if you highlight from a number of data points, you can now rotate your view if you have some data selected in the 3D biplot. If you hold down your Alt key while you have the selected data points active, you can choose to rotate your view. This function is also found on 3D variable plot, so your standard 3D spin plot, and you can also do this in 3D map view as well. The next thing I want to show is on the changes that we have made to the downhole plots in ioGAS. But before we do that, I want to show a new feature on how we can bring in a batch of files containing a same structure at the same time. So this is useful, especially if you're bringing in a batch of CSV files from lab assay results, for example. The batch importer can be found from the file ribbon, where you can choose to open these batches of files. So you can see here that it's in alphanumeric order. So it will choose to bring in the rows in the file in alphanumeric order. So in this case, the rows will be ordered from the first file and then to the second file and third file in that list. So you can see in the column properties dialog here that this file has a number of major elements, some in oxide, some in weight %. So just keep that in mind for now, and we will get to this in a bit shortly. So before we move on, I want to show this new tool in ioGAS that allows you to easily sum the major elements in this file as oxides. So as some of these elements are not in oxide form, this tool, which can be accessed from the calculation ribbon, and it will run on the select variables dialog as with any quick calc that we have in ioGAS. So if you see the elements that I've selected, some are in weight %, some are in oxide. So what it will do when I run this tool, so I'm just going to click OK and then go to the calculation ribbon, and I go to the sum button and I click on sum selected alias variables as oxide. What it will do is it will sum all of these elements in oxide form, and it will try to calculate the remainder, and we'll output them as new columns. So as I click calculate all in this dialog, it will calculate some oxides and missing oxides as 2 new columns, which we can see here. After I bring up the data view, you go to the end, and it will bring up the some oxides and the missing oxides as 2 new columns. So there's another option here. So if you go back to the calculation menu, and I select from a whole bunch of these elements again, there's another option if your data is all in oxide %. This option will let you sum all the selected alias variables just as %. And there's another option to recalculate selected elements in oxide based on 100% weight sum. So assuming that all of them add up to 100%, and it will recalculate the individual columns as such. So now let's look at the changes that we made to the downhole plot tool. So we've standardized the tools across downhole plot, line plot tool, wavelet tessellation found from the wavelet button in the analysis ribbon, and also in recurrence plot as well. So what this does is it improves the consistency between these tools, and it streamlines your workflow, especially if you use these tools regularly. Also does the same thing in the glinking tool in the XY plot as well. As a side note, before we look at our next feature, I want to point out that in ioGAS 7.4, we have included a new demonstration file for results from Osiris. So this file contains examples of spectral mineralogy results, so a typical gas file that's exported from the Osiris desktop application, which can be plotted up on Osiris specific diagrams and templates. So we'll release a separate video on this workflow, so stay tuned. So the next feature I want to show you is the merge columns tool. So the merge columns function is another highly requested feature. So that allows you to combine data columns easily in ioGAS. So we've added a number of special functions to this tool, such as automatic conversion between two data columns of different unit and oxide state. So this file has silica in 3 different columns, and I want to basically merge Si ppm to SiO2%. So the merge columns function can be found from the data ribbon. I've selected SiO2% and Si ppm in this exact order because this tool will basically look at the unit and element oxide combination of the first column in this list, and it will use this as the basis for merging the other columns. In this dialog, I have an option of creating a new column from the result of the merge, or to use the first column in this list, Si2%, as the destination column. Let's leave that as create new column and click OK for now. And in the next dialog that appears, I can choose to write a new name for the merge output. The next message that appears is it will ask if I wish to convert Si ppm to oxide percent. And because it detects that the first column in this list is weight percent, it will convert Si ppm to Si2%. And you can see the result here in data view in the new column that's been generated. Another type of workflow that you might try to do is if you have conflicting rows, say if you want to merge SiO2 ppm to SiO2%, there are overlapping rows as you can see here. So when our radio button is set to do not allow conflicts, we will get this error message when you run OK on this dialog. So it says that 4 rows contain values in multiple columns, and if you click OK here and choose the second radio button instead, it will choose to use the value from the first column in this list that contains a valid entry. So you can see how this will use values from the SiO2% for the overlap, and when there are no overlap, it will just run the conversion as expected. The last feature that I want to show you is error bars. So this is something that has been requested a number of times before by our users. So this tool requires error or uncertain information for an element to be present in a separate column. So for example, in this file, I have a TiO2_SD next to TiO2%, and the same thing for each of the elements that I have in this file. So you will need to have the elements selected in this exact order in the select variables dialog, because what we'll do next is we will plot these up as a scatter plot containing error bars. So this is a new type of plots in ioGAS, so you will need to use the select variables dialog to engage this function. So we provide this functionality in a number of new plot types for XY plots, which are basically the same XY plot types as a normal scatter plot, just with error bars enabled. So let's open the first one in this list. So this is a normal XY plot option, except that it displays error bars right next to each data point. So it plots the first column in the select variables list as the x-axis, with other columns as the y-axis, along with error bars next to each data point. The pairwise option is basically the same as a pairwise scatter plot, just with error bars enabled, and you can find them in the same drop-down list as well under the graph ribbon in ioGAS. So this is a brief overview of the error bar function, which concludes our video on some of the new features and improvements found in version 7.4 of ioGAS. This version also contains a number of other improvements and fixes. Some of these include Scott Haley's additions of new ioGAS rock composition nodes, which you can find in the rock composition tool in XYplot in ioGAS. So this also comes with a number of new classification diagrams on Kalgoorlie rocks, which you can find in the provided diagrams menu. And we've also made improvements to the way we report total rows and number of multivariate rows with calculation results. And we've also improved performance in the crosstab tool and improved the way map grid legends are displayed in ioGAS. So for more information, please refer to the What's New documentation in our help file, or contact us if you have any questions at all. Thanks for watching, and see you next time.
All right, we are back.
Hey, Putra, I just wanted to make a comment about the error bars. So it'll use, for error bars, it'll use whatever is in the column that you pick to make the error bars with. And that's quite deliberate. We didn't want to get into the debate about what type of error bars you wanted to plot, whether you wanted absolute or relative measures, and what measures you wanted to use, whether it was sort of a robust statistic or some type, or a standard deviation, relative standard deviation, etc. That's your choice about how you want to use that.
Right. So we'll just jump straight to the demo. Hey, Dave. So can you see my screen, Dave?
Yep.
Yep. All good. All right. So I thought I'll start off actually with edit data, because that is one tool that I went through really quickly in the video. So I went through a bit okay with some of the things like importing batch data, importing SQLite. So we're just gonna skip that. But yeah, feel free to ask me any questions if you want to see that in more detail. But for now, I'm just gonna open a demo data here from ioGAS, and then we'll just see what it looks like. All right, so I'm going to edit the content of this file. So it's pretty straightforward. So what you'll need to do is, it's basically contained within the data view. So what you'll need to do is click on the right-hand side toolbar. There's a button there that's called toggle edit mode. And once you click on that, actually what you can do is it will, sorry, I just have to stop that. All right. So you can click on the right hand side toolbar, and it's going to enable edit mode. And it actually says that data edits cannot be undone, and it's going to affect any checkpoints that's already been saved. So we do recommend people to save their file prior to editing. You wish to proceed, and then we click yes. It's going to come up with a red border here. And then this is basically an edit mode. So say, for example, if I see a typo in here, in this cell, you can make an edit there to whatever you want, right? You can just change that. That's going to be edited automatically. And you can sort of do the same thing with numeric cells as well. So say, for example, if you're looking at this cell right here that says 1, and you notice that maybe this corresponds, or maybe this 0.5 that corresponds to a certain detection limit. So if you notice that this actually corresponds to something like 0.2 or 0.1, you can easily change it like that. But of course, it's going to come up with a message saying that editing numeric data may invalidate values that uses that cell and that column to create any derived columns, and it asks you if you wish to proceed. So people do, if they want to use it, they have to approach this with a certain level of caution. And someone in the question and answers actually asked about the find and replace tool. So we do actually already have that function in ioGAS, but if you're familiar with the search and replace tool in GAS, is that you can't find a particular cell that you want to edit easily. So this allows you to do just that. But as Dave said and just before we ran on the video, he said if you want to do your edits, make sure your data is at a certain level before you bring into ioGAS, which is the endpoint for what you want to do with your data anyway. So I just leave it at that. But basically, that's what the edit data tool does. And if you want to exit this dialog, you just click on that button again, and that takes you back to the normal data view. And remember, everything you do is recorded under the change log. So if you change the file structure of GAS, if you change cell value content, that sort of thing, you do data doctor and stuff, that's going to be recorded inside the change log, inside the data ribbon. And then basically, you can tell if someone has edited your GAS file. So if you receive GAS file from someone else, I think it's a good idea to just look at the change log and see if someone's changed the underlying file structure using ioGAS. But yeah, I think that pretty much sums it.
That's a good reminder, Putra, that there is that change log. So, and that goes with the files. So because we keep editing functionality, it's quite important. So if someone sends you a GAS file and you wonder if there's been any changes from what came out of the database, you can open up that change log and just have a quick look.
Yep. So the next thing I want to look at is the user variable groups actually. So if you go to the select variables dialog, the provided user groups, so that's in its brand new drop-down list over here actually. So we have the standard provided element groups. So if you've used GAS for a while, you've probably used this before. But we also have provided user groups here. So I'm going to make a new test selection actually. So what I'm gonna do now is I am going to select, say, just a few elements from here, just some random ones, and then I'm going to click on this button here, So it says save selected alias variables to a new user group, and we highlight this because it at the moment it only saves alias variables, and that basically allows you to save a list of alias variables that you can reopen at any time using any other data set. Because what it does is ioGAS save this list in your installation. So doesn't matter what gas file you open, that user selected group will always exist, much as we do with the provided element groups. It's always going to be there. So I'm just going to create a new one there. It's going to call it demo save. Yep.
That's quite an important point, that we insist on them being alias, because if you add, just using that example there, you use copper_ppm alias. If you open up another file, it will find copper %. It knows that it still knows that it's copper, so it makes the tool far more useful than just relying on straight name matching.
Yeah, that's right. And you can do a few things as well with this. So you can take it out of the list. So you can remove any existing user groups, and you can make a new one. But one of my favorite things to do with this new tool is that, so say if you look at something like a porphyry group, and then and you only think that you're probably only going to be using the first 4 elements in this list. So what I did just then is I opened a provided porphyry group, but I just want to edit it so it only has these 4 elements. So basically that allows me to create my own porphyry edited group. So that's my own edited provided element groups essentially. And that basically, yeah, just allows me to do it from any gas file that I open at any time. And then the next thing that I want to show, so I'm just going to run through a bit about what we did with the principal components analysis tool, and then I'll jump to the merge columns idea, some of the workflows that we can do with that. So I'm just going to run through the PCA tool. So I'm going to select different elements actually. So in this file, just going to use this set of immobile elements, and I am going to run my PCA. So there's quite a few things that we have changed here. So I'm first going to run through just a normal PCA. So one thing to keep in mind is that people have been requesting before, if they have more than 12 columns selected, why doesn't the calculation generate more than 12 columns? So actually, I'm going to bring an example where I select all the variables here. So I got something like 32 elements here, right? So if I run the PCA, and we'll see what happens. So basically, the resulting 32 columns, they're going to be, it's in the dropdown list actually, hang on. Yeah, so I forgot to do that. So basically, what I can do is that I selected 32 elements, right? And in the past, it's limited you to only create 12 output principal component columns, but now you can select up to 32. Some people have reasons of wanting to do this, but we allow them to do this now in version 7.4. So, but for just this exercise, we're just gonna keep with 7 principal components, and I'm gonna create a couple of biplots as well to go with that. So the resulting output. So this is all pretty much the same. So the calculation, this part is still the same, but what we have changed really is the way that we have made changes to the 3D and 2D biplot, but also to the PCA report itself. Because as you may notice in the video, there's a new tab here called eigenvector plots. So if you're looking at this tab before in the past, the eigenvectors information, and you look at this the numbers here, some people may find it easier to visualize this graphically, and that's why we put this in as an eigenvector plot for each principal components. So that displays it from highest to from largest to smallest, and you can also adjust the common range scales. So I didn't show this during the video, but basically this allows you to adjust the common range scale to see the distribution of the eigenvectors a bit better. And then, as with most of these sort of tools in ioGAS, you can click on the copy all button to copy the result of this to clipboard. And then what you can do is, so I've shown you how we changed the report with the eigenvector plots tab, but we also made some improvements to the normal biplot that you generate from the PCA. So here's a normal, just a 2D biplot. So I'm gonna choose maybe the first one looks all right. So what we can do now is actually we have these 2 new options here to display point density grid. So in here, you may think that you want to see where most of the data points are concentrated in this pie plot, and it's likely to be here. So we just click on that, and we can sort of see the result of that being displayed on top of your pie plot. And you can, of course, right click on this. So remember, this is one thing that people tend to forget. This is one thing that we've added past couple of release, is that you can right click on most of these things in ioGAS, and then you can toggle through the options that we have available instead of manically clicking through this one at a time. You can actually right click and select the option that you want to display in. So 70% is quite good for this, right? And then another new thing that we have added is we can now display mineral and rock nodes on top of a 2D biplot. So in here, for example, I would just want to click. So we can't plot some of these ones. So I'm just going to click on some of these rocks. So let's just see if I can plot this correctly. So I'm going to click everything from this tab, and we'll see that they're actually displayed on this. So mineral and rock nodes that they work really well with PCA that's using alias geochem columns, and as a result, you can plot mineral and rock nodes on top of that. And that's something that people have requested before in the past, and it's a really useful workflow as well. Do you have anything to add to this section, Dave?
No, that's just makes those diagrams that much more interesting from an interpretation point of view.
Yep.
Especially if you have custom rock libraries.
Yeah, that's right. Yeah, especially if you have custom rock libraries, that's right. And I always emphasize that we've added that feature in the last couple of releases, but basically you can export your own user nodes. So if you see in the dialog before you have minerals, rock, or SNACA, you can have your own tab basically that lets you export your own rock interpretation and have a library of your own rocks as its own tab in that dialog. So one thing before I jump on to the merge columns function is that we've added a couple of new improvements to the 3D biplot, and this change is also reflected in 3D spin plot and 3D attribute map. So with 3D biplot, well, any 3D plot in GAS, what you can do is that if you select a data point using the flash highlighter, so we've added in the last release, but if you hold down the Alt key on your keyboard, you can spin while having selected points highlighted. And this was one of the pain points of the last release, is that if you have points highlighted in a 3D plot of sorts, you can't easily rotate your view. So this allows you to see highlighted points while rotating at the same time. So remember to hold your Alt key while you're rotating. But yeah, that's basically it. And now I'm going to run through an example of merge columns. It's going to open a different data set. So while we're on this menu, you can see I'm hovering over Osiris demo data here. So as part of IMDEX, we've actually allowed people to have a play around with Osiris demonstration data sets. I'm just going to click on that quickly. I'm going to show you that just a couple of minutes. So if you click on that Osiris demo option, it comes up with a couple of diagrams here that I've preloaded into the demonstration file. So that basically allows you to see what an Osiris output kind of looks like. So the Osiris desktop application actually spits out a .gas file, a .gas workspace file that contains output from their system that's loaded into Osiris desktop, and you can export it as a gas file that you can load into ioGAS, and you can open Osiris type classification diagrams that you can access from their own tab here under Osiris, just in case you haven't seen it before. But this means basically you can have a play with it, and then you can ask us any questions if you want to look at integrating this with your workflow. So I'm just going to open the drill hole demo data, and this is one thing that people might like to know if they're pretty new to ioGAS. If you're wondering if ioGAS can plot drill hole demonstration files, drill hole files in general, they can open the demonstration drill hole file in our open drill hole demo data. So I've already got this open, and the reason why I want to do that is there's a couple of workflows here that allows you to merge columns together. So in here, I'm actually going to create a couple of diagrams first. So I'm going to create this one. So the Halberg classification diagram first, and then I'm going to open another volcanic rocks classification diagram. So I'll run through this workflow of merging text columns together, and then I'll run through the numeric ones quickly because I've already shown you that in the video. But this is a pretty neat workflow. So what you can do is you can assign a filter based on where they're plotting in here. And then what I want to do is I want to color this. Actually, I want to first create a new column from the filter. So I'm going to call this the Halberg filter. And then I am going to color the results from here. Oh, but before I do that, I actually want to turn everything off here except the basalt. I think I must have clicked the wrong one. Just do that again. Yep. So now what I want to do is I want to create a new column here. And then what I want to do is I want to see what the output sort of looks like. So if you go to the right in its data view, and you see that I've created 2 new columns here to create 2 new from the filter and the color. So basically, if you're familiar with the use of the Halberg and the Pierce classification diagram, basically what I want to do is I want to subclassify the rocks that are within that basalt group. And I can use the merge columns function to do that. So I'm just going to bring those 2 new columns in detail. So you see, so if I just click on this, if I sort the column headers, and you can see the samples that are logged as basalt under the Halberg one, they're subclassified in the Pierce one. And then what I can do is I can merge these 2 together. So if I go to the merge columns option, and then if I put the second one, first one in the list. So if I just want to make sure that I have that Pierce 1996 is the first one in the list and the Halberg is the second one. Now I want to create a new column here, just to basically, I don't want to overwrite the existing column. And then you can choose conflict handling like this. So basically what this will do, and I'm just gonna bring up my data view again. It's gonna expand it a bit. So basically what you can see here is that if you look at the samples that's classified as basalt, just give me a sec. So if I just, I think this might make it easier. So that's the one that I merged together. So if you scroll down here, you can actually see that I have subclassified the rocks that are basalt using the basalt classification from the Pierce 1996 classification. And you can see the result when I colored up the result by that merge column. So if you go to the colors tab, if you do it like this, so whereas before you have recolored them based on that, but you're basically recoloring the result of basalt based on that subclassification that you see from that Pierce 1996 classification diagram. And then so that's the merging columns workflow, which is quite interesting, and it's a really useful workflow that allows you to subclassify, and then you can merge the result together. So now I'm going to run through an example of how you can merge numeric columns, and I think the value of merging numeric columns while we allow aliasing to be built into this is that it does the automatic conversion in the background for you, so you don't need to worry too much about it. So I'm loading this file, which has 3 different aliasing for SiO2. So one is in weight percent, one is in SI ppm, and one is in SiO2 ppm. So I've shown you this a bit during the video, but basically what you can do is, so say if I want to merge the result of SI ppm to SiO2%, I'm going to first select SiO2% as the first item in this list. And then you can select SiPPM as the second one. And I can choose to create a new column, or I can choose to merge it into the SiO2%. But we're just going to create a new column for now. And we don't have any conflict handling here, so it's fine for us to leave it at the top here. So let's see what happens. So what's going to happen is actually, so you're going to choose a name for the destination column. You can call it whatever you want, but the default SiO2%, SiPPM makes perfect sense to me. And then it's going to ask you if you want to convert the SiPPM to oxide percent. So that's exactly what it's going to do. So the result, so this is quite robust, right? So you keep the result of the SiO2%, but it's going to convert the results from here to SiO2 in weight percent. So that's pretty straightforward, and you can actually do this with multiple columns. So what you can do is you can select these three. So you can choose to combine this to this. So instead of just going this to that, and then of course, if I do this and if I choose to create a new column, but if I don't choose conflict handling, it's going to come up with an error because you see there's 4 rows here that have values that exist within both of these columns. So it cannot proceed with the merge. So you gotta allow a bit of conflict handling. So you're gonna see what happens. And then of course, because we have these two in different form to the first one, so it's gonna convert SiPPM, SiO2% to oxide percent. And then just click yes here, and you can sort of see the results of what happens. So this is pretty straightforward. So it's just going to convert SiO2 ppm to SiO2%, and it's going to do the same thing with here, and it's going to basically did what I did just then with the SiPPM and going to the SiO2%. And then so that basically covers everything, including the conflict handling here. So I think why we put this into ioGAS in this way is that it allows for the automatic conversion of units in the background. So I've shown you the text columns merging example, but you can also, of course, merge numeric columns together. It's a way for you to merge multiple classifications together at the same time. So I've run through most of these. Anything you want to add, Dave? I'm just scanning through the list just before we wrap up.
Yeah, no, I think that was great, Putra.
Yeah.
It's a chance now for anyone to ask any other questions they might have using the GoToWebinars.
Yeah. So before we do, I'm just gonna run through the some oxides example because I did go through that fairly quickly during the video. So I'm just gonna open a new file, and I think this file should have a bit of weight oxides here as well. So I'm just going to run through a couple of things before we finish off with a few Q&As and discuss any lingering things. Basically, we have streamlined the way we display things in downhole, line plot, glinking, and any other that sort of similar looking tools. So wavelet, tessellation, recurrence plot. So in 7.4, we have actually made the interface kind of similar for line plot, downhole plot. But what I didn't show in the video was that actually we change it up in glinking as well. So if you use glinking quite a fair bit, we changed sort of the dialog to be it looks a bit so the workflow is quite similar to how you would configure line plot, for example. So any line or drill hole based tools, we made the interface kind of similar-ish, and you see the same thing under wavelet tessellation. Yep.
Putra, I can see Liam is online, but just to point out that glinking is named after gatehouse linking, Simon, and Liam is online, so you can tell your old man that's why we called it glinking. Sorry.
Yep.
But with that.
Yep. That's it basically. So I see we can do the same thing in recurrence plot as well. So the dialog is pretty much the same. And the reason why we do that is because we just for consistency and just for the same logic that applies to everything. So if you use a wavelet tool, this makes a bit more sense now. But why am I showing this? Another reason is because we have changed the way that we display the vertical axis here. So we have the option of displaying it as either depth or elevation. So if you're plotting downhole plot as a function of RL value, you can actually display it as elevation instead of as depth. But since we're plotting depth from in depth to, we just choose the vertical axis as depth. But that's pretty much it. But that's one thing that's quite important. So if you're plotting RL, just make sure that you put it as elevation. So then that's the same thing. So wavelet by default is plotted as depth from instead of elevation. So before we move on, I'm just going to see about that sum oxide example. So this file has a few major oxide elements. So I'm just going to select the major elements here. So what I'm going to do is, so you see this list here. So you have some in oxide percent, but you also have some in weight percent. And you can sum all these guys in oxide, all in oxide, right? So just keep this in mind and click OK here. And if you go under the calculation, if you go under the sum option here, so this is a new button. If you click down, there's a few options here that you can choose. So you can choose to sum selected alias variables as oxide percent. And then because our FE was in just weight percent, so you have an option of choosing FE203% or FEO%. So I'm just going to select FEO%, and for this, this is straight oxide. And you see what it does here is that it generates the input column based on that conversion that I chose earlier. So FE as FEO, and everything else as I instructed it. And it's going to generate a sum of oxide, and it's going to generate another column called 100 minus sum oxide. So there was a question earlier in the chat about whether you can use this to calculate, back calculate SiO2, sort of like fake SiO2, if that makes sense. But yes, you can sort of do this workflow for that work. That's one of the reasons why we put them into ioGAS. But the important thing about this is that it does the conversion to oxide automatically for you. So you have this option. But if your data is already an oxide weight percent, you just click on the first button here. But since we have a mix unit, we just select the second option. So I'm just gonna click select that. So this is semi-real data, so the result may not make too much sense. But if you go to the right, you see one of the output columns. So you see the sum oxide here, and you have the missing oxides that's recalculated as well. So some of this, so a few of these rows make a bit more sense, right? So it sums it up as 98%, and the missing oxide is 1%. So just things like that you can do with that menu. And of course, if all of your data is in oxide weight percent, so for example, if I convert this to oxide, and then if I choose, I can basically just choose to create this using everything in weight oxide. Deselect everything, and basically if I want to select everything in weight oxide like this, what I can do is, probably don't want that carbon and sulfur, so I'm just going to select, so all of this is in oxide weight percent, and basically I just can click on that first one to calculate my sum like this, and that's pretty straightforward like that. And then you can also recalc selected alias variables to 100%. So basically what that will do, and I didn't show this in much detail during the video, but you can basically recalculate it based on a sum of 100%. And the output column can be displayed as such. So if you look at it to the right-hand side, you can see the recalculated oxide weight percent based on that 100% sum. So we got a few minutes. I just want to show you a couple of things that I didn't go through in too much detail during the video. But basically now we have a few new, that's probably not the right one, but we have a new ioGAS rock composition. And then you can see where they are at under rocks, under ioGAS rock composition, and under references here, you can sort of see where they come from. So Scott Haley has helped us compile this list. And yeah, you can basically plug this if you're working in the ioGAS and the sort of rocks that you're looking at as a reference. And you have a few new diagrams, as I mentioned in the video as well, and that's based on that. So yeah, that's it. I think that covers most of it, Dave.
Yeah, thanks, Putra. I'm just answering a couple of questions on the side. Yeah, look, that was great. If we haven't gotten around to a question or one occurs to you after this webinar, then just send us an email to our normal contactable email address and we'll get back to you about that. For your co-workers or other people that you know that use gas, if they've missed this webinar but would like to see it, it is being recorded and it will go up on our website probably within the next few days, I think. So it'll be there for you to come back to if you want to see something again or if you want to share it with some other people.
Thanks, everyone.
So that concludes it. So right on the hour mark almost. So that's great. Thank you very much, Putra. Thanks everyone for attending and have a lovely day, evening, afternoon, wherever you are. And we'll see some of you around the traps when we can finally escape West Australia again and travel. Bye-bye, everyone.
See you all.